Okay, so now it's recording. But then I need to upload the. Upload the video. So let's try to see how we can convert 128.
Doctor,
No,
can you make it a decimal number?
excuse me.
Can you make it a decimal number?
ما فهمت سؤاله. I did not understand the question. Can we what?
Can you give us an example with a decimal number?
What do you mean decimal number? This is decimal number.
I mean with
What's the question? I don't understand. Yeah. What do you want to do with the decimal number? Yeah?
I think he means like 128.5.
yes.
Oh, okay. With the fractional part. Okay. We can try. Like 128, for example, or let's say 12 point. I don't know. Something like this. Okay, we'll do this later, but let's see with 128. Maybe I think 128, 28 we cannot represent it on 7 bits. I think it's the eighth bit that will be 1, but we'll see. This is 64. So I think the example is not valid. So here we have 0 divided by 2, 32. 0 divided by 2, that's 16. 0 by 2, that's 8. 0 by 2, that was 2, and the remaining is 0. Divided by 2, that's 1, and we have 0. So we have 8 bits, so we cannot represent this number using the side magnitude on 7 bits. Okay, so this is not a good example. So that's not a valid a number we can represent using 7 bits and sign bit. So let's take this example here. So these numbers just put these numbers here just now this was not in the exam last year, so we can try with 126, for example. So let's take this this number. So you said you want to convert it to binary, huh? Okay, so we have to make the conversion of the integer part and then the fractional part. So 12 to convert it, we can do it directly. That's 1001 1010. Sorry. So this is 8. No, that's 1100. So this is 8 and this is 4. So it's 1100. Okay, you can find it easily by doing the successive divisions. But for the 035, this is different. So you have to write 0 point. So you have to write let's say 0 point, and then you multiply by 2 successively. You get 0.7. You have to report this 0 that you find here. And any integer part that you find here, you have to report it on the result in each step. So this 0 here, you have to report it on the result, and then you go to the next step. So 0.7 multiplied by 2, that would give us 1.4, and then you report the 1. You take the 1, you report it on the result, and you continue. You are left with 0.4 multiplied by 2, you get 0.8. You report this 0 on the result, and you continue. We already have encountered this 0.8. This will be infinite. So we have to stop somewhere. So let's say 8 multiplied by 2 would give us 6, 1.6. So we report the 1. And let's say we say that our system supports only 4 bits for the fractional part. So we have to stop after 4 bits. And we have to ignore the remaining information or data. Okay, so this 6 here will be neglected, will be ignored. So we will have an approximation of this number. يعني هنا we will get 1100.0101. Okay, this is not exactly the conversion of 12.35. Why? Because this 35 هنا is not and it cannot be converted to 2 exactly. We can only make an approximation of it. Okay. Is it clear or لا?
Yes.
Is it clear the idea of approximation?
Yes, clear.
Because we have to stop somewhere. We have a limited space, memory space, let's say. We have, let's say, reserved a space of 4 bits for fractional part. So here we have to stop somewhere. So this depends on the system that you are using. Okay. So usually in the exercise tells you how many fractional numbers or bits you can have. So you have to stop at that level. Okay, let's go to the next question here on the exam. So you have this operation, and you need to do this operation. So this is 55 minus 89 using sine 2's complement representation system. Okay, so you have to make the conversions first. This is not the one. So the operation is 55 minus 89. Okay, so we have a positive number here, 55. We need to find its representation using the 2's complement system. So 55 is, let's say, 32. So one. We try to do it directly without making the divisions. 1, 2, 4, 8. Okay, so we have 32 plus 16. That gives us, this is 32 plus 16. This gives us 48. And then we need 7. So 0 for 8. We need 4. We need 2. And we need 1. Okay, so this is 1 plus 2 plus 4. This is 7. Plus 16 plus 32. That's 55. So here we have only 6 bits. We need to add the 0 to complete the 7 bits of for the magnitude part, and then 0 for the sign bit. So this is the 2's complement representation for 55. And then we need to find the 2's complement representation of 89. Okay. So here, can we do the same approach? We can. Here we have 64 plus 32. No, we cannot add 32, so we have 0 for 32. We can add 16. 64 plus 16, that makes 64 plus 16. That's 80. So we need the 9, so we need 8 here, and then 0, 0, and 1. Is it clear? Is it clear how I found the binary representation?
Yes, sir. Yes, it's clear.
Okay, so here we need to convert to 1's complement by flipping the numbers. So here 0, 1, 0, 0, 1, 1, 0. We add the 1 for the sign, and then for the 2's complement, we add 1, 1. It's difficult to write with the so 1, 1, 1. Okay, so this is our number. So now we need to make the addition. We have 0, 0. Maybe it's easier to write it as a dot. يعني in Arabic يعني way have small dots. Okay, 0. Okay, I write 0, 0, 1, 1, 0, 1, 1, 1. This is 55, and then we have 1, 0, 1, 0, 0, 1, 1, and 1. And here we make the addition, no? So here 1 plus 1, this is 10, 0, 1. Here we have 11. Then we have 11 again, 1, 1, 10, 1, and here we have 1. Okay, so we have a negative number. To verify that the result is correct, we convert this back to 1's complement, so we subtract 1 here. So we get 1, 0, 1, 1, 1, 0, 1. Okay, I took only the magnitude bits and I subtracted 1, and then we flip back again to the signed magnitude representation. So we get 0, 1, 0, 0, 0, 1, 0. Okay, so how much is this? Okay, we don't forget that this is a negative number, so this is 32. 1, 2, 4, 8, 16, 32 plus 2. This is 34. Okay, so we should, this is of course minus 34. So that's correct. Okay.
دكتور
نعم.
ممكن ترجع اللي قبل شوي؟
Yes.
أنت خذيت الرقم من اليسار واليمين غيرته.
نعم، هو هنا this is the 2's complement representation. عشان أتأكد to make sure that this result is correct, I need to convert back from the 2's complement representation to the normal representation that we can understand, يعني, that we can use to go back to the decimal system. You cannot go directly from the 2's complement to decimal system. You need to go back to the 1's complement and then to the sign magnitude representation, which is this one. Here you subtract 1 bit. Here you flip all the bits, and you get, here you can convert from binary to decimal using the normal conversion that we know. Okay.
Okay.
Okay, here draw the exact electronic diagram without any simplifications for this circuit. I think this is easy. I think, no. Well, you want me to do it? Huh?
Do the next one instead. It's a
This
bit
one?
harder بس حتى هو سهل شوي.
Yes, the second one.
Okay. Okay, so I don't see the number. So it's A, B bar. So we draw the input lines for A, B, we need B bar also, and then we have C, we have A bar also, and then we have C. We need B bar or C, B bar or C. This is B bar or C. We need AND B, so this is ANDed with A, sorry, with AND A. This is ANDed with A. And then we have OR A bar B, so we need A bar B. This is an AND, and these are OR together. Okay, is it clear?
Yes, it's clear.
Yes.
Okay. بعدين complement the following. Let's try to complement this one. هنا maybe doing it هنا is better. So هنا F4 prime is equal to
A and B bar.
A prime or B maybe I have to write this A or B. So all of this bar, is it okay? Is it okay or لا?
Yes.
I just copied everything between parentheses and I put a bar هنا. Okay, so this is equal to the first one bar plus the second one bar. صح ولا لا? Am I correct?
Yeah, it's the Morgan's law.
We just copy the other one the what's inside. Okay, so now we can open the or apply the first bar that is here. So this is equal to A bar bar, which cancel each other, and B bar. Okay, is it correct? Is it correct?
Yes.
Here,
Yes.
this bar applies only to B, yeah? Doesn't apply to A. That's A and B bar. And for the second one, you get
هنا
A
ما
bar.
نغير الأور لأند.
نعم.
هنا ما نغير الأور لأند اللي
هذا
جنبها. إيه.
لا هذا الأور it's outside of the story. يعني هنا عندك and of two things. You just keep it as is يعني. You keep the or. You are just transforming this one. You are just applying the transformation of this term هنا بس. الحالة. Same thing. You are applying a transformation for this term الحالة يعني independently. So the or هنا is not affected. It's affected هنا. It was affected هنا. Why? Because it's inside the bar. It was below the bar. يعني هنا we have x and y bar. It becomes x bar or y bar. هنا it changed because it was under the bar. but here it's not under the bar. Okay.
Okay.
So here you get, and for the second one, what do we get? You want to try?
A bar and
Naam,
B.
A bar and B bar bar, which cancel each other, so we get A bar B. So that's the final result.
دكتور عندي سؤال.
نعم.
لو اكتب بالاختبار بس الفاينل انسر من غير خطوات عادي ولا ما ينفع؟
If you did it directly from here, you can do it directly from here by يعني applying the duality rules. Like here you transform each A by A bar, each plus each R by and so on, and each AND by OR, you get the result. Okay, if you did this, yani it's okay. Okay, but yani if it's something yani that doesn't come from some yani something that we see that you applied something yani. Hina you can, but yani sometimes if there is a simplification or something, we need to see how you did the simplification. But here we don't have any yani. For the complement, usually we don't have simplifications. We just have yani. The answer is yes, you can. Hina. Okay, so then convert the following expression to its canonical sum of mean terms, then its canonical product of max terms, representations, using truth tables. Okay, this will be a little bit more difficult. I mean, with the mouse, يعني to do this with the mouse. But we'll try. واضح الشاشة؟
ايوه واضح.
واضح.
طيب هنا we need a truth table, so it will be a little bit يعني difficult to draw. عندنا A B C 0 0 0 0 1 0 1 sorry but يعني بالماوس صعبة 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Maybe if we do it directly on a table, maybe it will be easier يعني. Okay, let's continue. هنا A and B bar or C. You can do it in steps if you want. And you can don't take the A, just يعني so that يعني you make less errors. B bar or C يعني you need that يعني if C is 1 it's 1. So هنا it's 1. هنا it's 1. هنا it's 1. وهنا it's 1. When B is 0 it's 1. So هنا it's 0. هنا it's 1. هنا it's 0. وهنا it's 1. Is it okay how we fill this column? Is it clear?
Yes.
Okay, now we make the second part. So A and let's call this T. A and T. Now we get, so whenever A is 0, it will be 0. And here it will be 1 whenever T is 1. Clear? So
Yes.
then you have BC bar or BC bar. So BC bar, you need B to be 1. So whenever B is 0, this is 0. Here it's 0. Here it's 0. And here it's 0. And then you need C to be 0. So this is 1 and 0. And here, this is 1 and this is 0. Let's call this X. Let's call this Y. X or Y, which is F. No need to call X and Y. I could have written يعني هنا F5. That would have been easier. So هنا you have 0, 0 or 0, 0 or 0, 0. هنا you have 1, then 0, and then, can you help?
1 1
No.
1 1.
1 1 1 1. Okay. So هنا that's okay. So for the mean terms, canonical sum of mean terms, you can write that F5 is equal to sum of the mean terms Mi. Okay, I will write it here. That's much easier. F5 is equal to sigma. Okay, sigma is a little bit difficult. Okay, I will write it here لأنه I will have to look for the sigma يعني and insert. Okay, so sigma Mi of mean terms 0 1 2, mean terms 2 2 3 4
5, 6, and 7.
5 6 and 7. This is also equal to the product of the max terms 0 1
3.
and 3. If you want to write the details, here I will write the mean terms. So the mean terms, I will not write them, but I will write them here because it's easier. So mean term 0 is A bar, B bar, C bar. Oh no, mean term 2, sorry. So mean term 2 is A bar, B, C bar. 2 4 5 6 and 7. Okay. And then is it clear انه mean term 2 is this one? Is it clear?
Yes.
Is it correct?
Okay.
Okay. Then mean term 4, how much how do we write mean term 4? That's
Midterm 4, it would be 1, 2, 3, 4. It would be A bar. No, A, B bar, C bar.
A, B bar, C bar,
Sorry.
correct. Then mean term 5,
5, A, B bar, C.
A, B bar, C. Mean term 6,
A, B, C bar.
and then mean term
A, B.
7, A, B, C. You just need to remember either أنه mean term 7 is ABC or أنه mean term 0 is A bar, B bar, C bar. That's all you need to remember, and then you can find all the others with the logic we can also write that F5 is equal to the product of max terms. So max term 0 will be can help me?
Maximum 0 would be A bar, B bar, and C bar.
No, that's the max term. The max term تاخذ opposite.
فتكون A B C حتى
نعم, that's A or B
or C. Okay.
or C. You have to choose the max term that will be equal to 0 when A is 0, B is 0, and C is 0. That's the only one يعني that will be equal to 0 for those inputs. Mean term or max term 1.
It would be A or B or C bar.
A or B or C bar, correct.
The minterm 3 would be
A
A
bar.
bar.
Are you sure?
Uh, A plus C, B bar plus C bar
A or B bar or C
or
bar.
C bar.
Okay. So that was the that question. Then this is saying demonstrate by means of truth tables the validity of the following identities. I think this is easy.
Very easy.
Okay, what about this one? Here it is saying using K-maps, find the simplified sum of minterms of the following expression. Draw its diagram using AND OR and NOT gates. Give the cost of your solution using the G cost criteria. Okay.
هذه سهلة بس طويلة والله.
نعم, it's a little bit long يعني, but not very complex. Do you want to do it ولا do you have any other questions?
لو تقدر تفضلنا على دي.
نعم.
You mean I attempted?
لا لا, I mean, do you want me to do it or do you have other questions يعني more important than this? And do you think this is important to do or do you want to do something else? That's it.
Yeah, yes please دكتور. Yes please.
We do
Just
this
cover
one.
this again.
Okay.
Yeah, it's the same one as we did أمس صح؟
I'm not sure it's the
نفس
same
الوضع.
function. I don't know, but يعني let's simplify it. Let's do this one. Maybe it's not the same function. Let me remove the A هنا, or otherwise we'll have ABC and AB. That will be يعني ABC will be يعني just simplified directly. So هنا, okay, I'll keep the same truth table. I'll keep this truth table. Oh, ABCD. Oh, okay. I'll do it here because we'll have a longer truth table than the other one. So maybe here it will be easier. Not very convenient. Okay, so we need, here I have here A, B, C, G, and here I have F. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 10, 11, 12, 13, 14, 15, 16. I'm not sure if I can copy this, No. 0, 0, 0, 0. Here we have 0, 0. then we have I think it will be something like this. I'm not sure. I think it will be like this, but yeah, let's here we have 1 1 here it will be 0 1 0 1 Is it correct? It's correct. Okay. So by means of truth table, we need to fill the truth table. So maybe here we need more columns, so that we do it step by step. Insert column to the right. Let's make it smaller. Okay, here we'll take A and B. But in here we have A and C or D. Here we have B, A and C or D. Is it okay? Is it okay? Are you following?
Yes, yes.
B or D. And finally, we need another column. Insert column to the right. This would be F. Okay, so A and B. So whenever we have zeros, it will be 0. I mean, whenever A is 0, it will be 0. And then whenever B is 0, it's 0. And then whenever both of them are 1, it's 1. A and C or D. A and C. So whenever so A and C or D, whenever A and C are 1, A and C, where can we find A and C 1? In this line, this is 1, this is 1, and this is 1, and this is 1 because of A and C. And then or D. So it's also 1 whenever D is 1. Then it's 0 everywhere. Is it correct? Is it correct, Are you following this?
Yes, yes, correct.
Okay, now here it's B and this column. So here whenever B is 0, it's 0. So here it's 0, and here it's 0. And then it has to be, so here it's 0 because, sorry, here it's 0 because of A or D. Here it's 0. And here it's 0 because of this 0. Yani. And then here it's 1 because of B, and because of both of them. Then here B or D. So B or D, whenever B is 1, is 1. Here it's 1. Then we look at D. Here it's 1. Here it's 1. You can just copy also these chunks of, you can copy all of this and put it here. Is it okay, Hadi?
Yes, yes.
Okay, now whenever C is 0, this column will be 0. So it's 0 هنا and هنا. And then otherwise it's 0 when this column is 0. Otherwise it's 1. Hina 1, hina 1. Because both C and B or D are ones. Okay, now we have AB or B. Let's color these columns so that we don't look at other columns. These are the only columns we need to care about now. So F is 1 whenever any of these columns is 1. So this is 0, this is 0, 0, 1 because of this one, 0, 1, 1, 1, 0. Are you okay?
Yes.
This is 1. Here it's 1, 1, and 1. So this is F. Okay, now we need to report F on a K-map. Okay. Okay, so I will do that. I'll just copy this. Sorry. I will just copy this column. Insert table. Sorry. Huh? Okay, this is F, and here how to draw another table here. So we need a K-map with how many columns? So we have 3 variables. How many variables do we have? I forgot. We have 4 variables. So we need 4 rows and 4 columns. I mean 5 rows and 5 columns for the labels. Okay, so here we have 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Here we'll have A, B, C, D. Okay, so we have mean term 0. So let's color them so that also here 4 by 4. Okay, so we have 0, 0, 0, 1, 0, 0, 0, 1. Then we have 0, 1, 1, 1. And then you have 0, 0, 0, 1. We jump here, 0, 0, 0, 1. And finally you have 1, 1, 1, 1. So it will be here 1, 1, 1, 1. Is it okay how we filled the table? Hmm?
Yes.
Are you okay with that? Okay, just to make things clearer. Okay, so these are the labels. Okay, so what are the groups here? For this one here, the group is clear. It's this one. Okay, so we have this group. integral. Okay, so this will give us AB, and then I put the rectangle back. What else? For this one here, we can take this square, no other choice, and you have to take that square. Is it okay?
Yes.
So this is B and
D.
B and D. And then what about this one? We have to take the column. So this will be
CD.
CD. And finally, we still have this one here left. And here we can also take a square. We also here can take a square. So this will be what the result will be here?
B
Okay.
و C.
B and C. So here we see that B can be put on
بس دكتور عندي سؤال.
نعم
عندي سؤال.
نعم.
Which of the following are essential and which are not?
So all of them are essential here. We do not have any prime implicant يعني that covers يعني هنا every prime implicant has at least one mean term that it is the only one to cover it. يعني هنا مثلا البرايم implicant اللي هنا is the only one who covers this one. البرايم implicant اللي هنا is the only one who covers this bit هنا. بالنسبة ل this square also is the only one who covers this bit هنا اللي هنا هذا one this one. Same thing for this square. It's the only one who covers this bit. So they are all of them are essential.
Okay.
So that's the function. And then so what does it say? Yani what's the question then? Oh, it's here. The question says draw the diagram using and or and not gates. Give the cost of your solution using the G cost criteria. Okay, so here we have two circuits, or we have two expressions. Each expression can be used to يعني will have a different cost. These two will have different costs. We did not see how to compute the cost on this kind of equations. Let's go to the slides to see how we compute the cost. So that was in chapter 2, I think, the first subject. It's this one here. So G is equal, how we compute G, all literal appearances. So the number of inputs to the gates and the employee corresponding exactly to the given equation or equations. So for SOP and POS equations, it can be found from the equation by finding the sum of, so you see in the definition, you need the SOP or the POS equation. So if you have something that is mixed, you cannot compute G, okay? You need either this representation using sum of products or a representation using a product of sums. So here you compute all literal appearances, the number of terms excluding single literal terms. So here you have 8 because you have 8 literal appearances, 1, 2, 3, 4, 5, 6, 7, 8. And then you have 3 mean terms. So you add 3 excluding single literal terms. If you have plus A, for example, you don't count it again. Optionally, the number of distinct complemented single literals, this is for Gn. So here G will give us 8 plus 3, and Gn you have to add the not. You have to add 3 for the not gates. So we will use G, so we can only compute it on the first expression. So here we have 1, 2, 3, 4, 5, 6, 7, 8. Is it correct now? 8 plus 1, 2, 3, 4. Okay, so here G will be equal to 12. 8 plus 4. Also Gn will be the same, and we don't have bars here, so Gn is also 12 because the complements are are 0. We don't have any complement. And then we have to draw the diagram, but I think we can do that. Okay. Do you have any other questions?
I have a question, Doctor.
اتفضل.
If you can go back up to the K-map.
No.
For the first square on the left, how do we find the letters? You put B and D.
This one?
Yes, this first square. How did we get B and D for a square?
لأنه هنا on these two columns, two rows, B doesn't change. B is 1 هنا and also 1 هنا. And for the two columns, D doesn't change. So you have to take B and D.
So you look for the numbers that do not change and you put them.
Yes. In this group or for this group, you have 2 rows and 2 columns. So for the rows, you take only the variables that do not change. And then if it's 1, you take B. If it's 0, you take B bar. So here it's 1, and you take B.
Okay. Okay, thank you.
Welcome. Any other question?
Will this only be the subjects that will be covered in the midterm, or there's more?
Those are the subjects. ما في other subjects.
في proof or algebraic manipulations ولا ما في؟
No, not in this one. Not in this exam. The next one, inshallah.
Would there be any conversions, Doctor, like the one in the first quiz?
The conversions, the ones that you need, like in the first exercise, for example, and also if you make an addition, for example, you need to convert. Exactly the ones that we had in this revision.
Okay, thank you, Doctor.
بارك الله فيك.
ودكتور بيكون تقريبا نفس عدد الأسئلة وبيكون الاختبار ساعة صح؟
نعم هو the difficulty is just in the length of the exam. The exam is easy, but you have to work quickly. You have a lot of questions, so it's 1 hour. You need to do all of this. يعني you need to be quick يعني. But the questions are easy. Okay, if you don't have any other questions, we can stop here, okay?
Okay, thank you.
بارك الله فيك. Okay, so I'll stop recording.